Alright, last lesson of chapter 7. We are probably going to spend a few days on these, depending on what the other classes do and how in depth they go. So, we'll see what actually happens. System of equations is a set of two or more equations that contain two or more variables. And the solution of a system of equations is a set of values that make all equations in a system true. It has an x and a y, so it's an ordered pair. Okay, and that ordered pair makes that system or those two equations true. So, we're going to solve each system of equations. On A, y equals 4x minus 6, and the second equation is y equals x plus 3. And what we're going to do is we're going to be doing some substitution to find out what x and y both equal. Okay, so if you notice, based on that picture in the middle, it's not really a picture. A picture to me is something fun. This is not really fun. But both of these equations are y equals something. Y equals 4x minus 6 and y equals x plus 3. So because they're both a y equals something, we can set those two equations equal to each other. We can take what the y equals and set them equal to each other, just like we did here. So we have 4x minus 6 equals x minus 3. And what we really did is we took this 4x minus 6 and we substituted it in for y. Okay? So now we are going to solve for x. Both sides have our x on them. Okay? So the first thing we need to do is we need to get x by itself. And in order to do that, we are first going to move the variable. Remember, we like to move the smaller variable if they're both positive to keep the variable positive. So in this case, the x is smaller than 4x, so we're going to subtract 1x because it's positive on that right side. So we're going to subtract 1x. 4 minus 1 is 3. We bring our negative 6 down, and our x's cancel out, and then we bring our 3 down. Okay, now we need to move the constant from the variable side, which is negative 6, to the right side. So the opposite of subtracting 6 is adding 6 to both sides. That cancels these out, and we bring our 3x down, and 3 plus 6 is 9. Then we need to solve for x. So we need to divide by the coefficient, which cancels these out, and 9 divided by 3 is 3. So we have found that x equals 3. And now we need to substitute 3 for x in one of the original equations. We can use 4x minus 6, or we can use x plus 3. But x plus 3 looks a lot easier because you only have to add 3 to what your x is. So we're going to take y equals x plus 3. In for x, we're going to put a 3, and we have 3 plus 3, and we get 6. So our x is 3, our y is 6. Now look, if we use 4x minus 6, and we put 3 in for x, we would get 12 minus 6 and get 6. So you can substitute 3 in for either equation, and as long as you do the math right, you'll get the right answer. The important thing for your solution is that you put your x point or x answer first, and then your y point or your y answer second. If you wrote that solution set as 6, 3, it would be saying that your x is 6 and your y is 3, and that's not the case, so you would not get full credit. You need to put those in order, just like you have a coordinate point that you are graphing on a coordinate grid. Alright, this one is a little bit more difficult because if you notice, you don't have an x equals something or a y equals something. It's x plus 4y equals negative 10 and x minus 3y equals 11. So what we need to do on these is we need to look and see if either variable has a coefficient of 1 on both of these equations, and it looks like it does. The x has a coefficient of 1. Okay, so we're going to solve each equation for x. So we're going to have x plus 4y equals negative 10, and we're going to have x minus 3y equals 11. So because we are solving for x, we need to move our y term to the other side. So on this one, we have positive 4y, so we're going to do the opposite of adding 4y and subtract 4y from both sides. That cancels out my 4y's here, okay? So I bring my negative 10 straight down, minus 4y. Now I go to the other equation, and I want to solve for x as well. So I look at my y term of negative 3y, or minus 3y, and the opposite of minusing 3y is adding 3y. That cancels these out. My x comes down, my 11 comes down, and then I put plus 3y. Now, because they're both x equals something on both of them, I can set what x equals equal to each other, just like we did in the example before when y was equal to something on both of them. Or, not or. So, now I need to solve for y. Okay, so the first thing I'm going to do is I'm going to move my y variable. And remember, I always try to move my smaller y variable, so hopefully my variable is positive in the end. It's not always worked that way, but it's a good possibility. So out of negative 4y and 3y, negative 4y is smaller. So the opposite of subtracting 4y is to add 4y to both sides. So these cancel, and my negative 10 comes down. And then my 11 comes down, and 3 plus 4 is 7y. Now I need to look at the side with the variable, and I need to move my constant. 11 is being added, so I subtract 11 from both sides, so it cancels. Negative 10 minus 11 is negative 21, and my 7y comes straight down. And now I have a one-step equation, so I need to divide each side by the coefficient, which in this case is 7. These cancel, and I have negative 21 divided by 7. I have one negative, so my answer is negative, and 21 divided by 7 is 3. So my y is negative 3. And now I'm going to take either equation, either x equals negative 10 minus 4 or x equals 11 plus 3y. It doesn't matter which one you use, and I'm going to substitute my y value in for it. They decided to use negative 10 minus 4 times y. So I'm going to substitute negative 3 in for y, negative 10, and then negative 4 times negative 3, because there's two negatives, equals a positive, and 4 times 3 is 12. Negative 10 plus 12 is 2. So the solution is x is 2, y is negative 3. Okay, you go try and do your, check it out. That one goes along very well with example 1. So I would suggest you look at example 1 as you're trying to work that out, and make sure when you write your solution, your x value is first, followed by your y value.